Hi, we're Group 2. We did the Blauwe Tram. I'm Christopher Weil.
I'm Marie-Claire Sobmana.
I'm Jacob Engel.
I'm Michaela Wilson.
This is our full assembly. It was a combination of a month of work from the entirety of the group. It required really strong communication between the four of us because there are 357 total parts in this tram. All of us had our own individual sub-assemblies that we then combined at the end to create what you see now. If any of us had something wrong, we really wouldn't have known about it until the final combination. But luckily, because we communicated very well during the entire process, everything went together way smoother than expected.
This is the wheel and brake subassembly. It has all the parts for the wheel and axle and the brake springs and the connecting spring straps, as well as the wheel skirting that sits just above the wheels. For the subassembly, the wheel skirting was one of the more difficult parts. Getting the correct angles on the front and back edges while keeping the top and bottom edges of the angled part level with the side brackets was the biggest problem. To create the angle bracket, genitive shape design was used, and the upper and lower profiles for the angle bracket were created and then connected to each other to create the overall outline, and then they were filled to create the shape that is shown in the bottom right corner of the slide. And then from there, the surface was joined together to become one, and then closed to become a full solid surface, and that's how that part was created.
Okay, so I was responsible for modeling the electrical contact that sits on top of the tram and translates the energy from the tram lines down into the motors. This consists of an electrical contact on the top, dampening springs, stay supports, hinges, restrainers, and base and foot assembly that mounts to the top of the tram. So one of the parts that actually gave me the most difficulty were the damping springs. There are two types of damping springs you can see on the left and on the right. The larger diameter damping spring on the left is for the base assembly, and the one on the right is for the stay supports. And the issue with this part was the continuation of the helix feature to construct the hooks at the end. Basically, sweeping the circular profile along the helix resulted in the initial profile being planar, but the other end, the final profile on the top side of the helix, was not planar. And then connecting that to the spring, you can see in that center image there would remain a gap from the non-planar profile. To fix this, I acquainted myself with the solid combine tool to fill the space between the faces shown in the center image. Another part that gave me a bit of a hassle was the bottom stay support subassembly. Due to the interconnected nature of the overall assembly, all of these parts had to fit perfectly within the overall assembly, and this was challenging because the vertical dimensions for the support bars was not given, and you can see in that top right image that it does change in vertical position as well as in diameter. And any discrepancy between that vertical change would adjust the horizontal position as well as the reverse support side through the restrainer. So the presence of the restrainer bar meant that this assembly had to be perfectly symmetrical, and any deviation in the vertical or horizontal direction from the non-properly dimensioned stay supports would translate through the entire assembly. The necessary fittings for these stay supports are shown in the bottom two images for the stay block and the support hinge. So the change in diameter and position had to be accounted for in the stay supports using the GSD workbench.
This is the front tram that I created. On the top of it, we see the control cabinet, capacitor box, the destination sign, and the air vents. I created those individually in part design, and I had to assemble them on the top. Also, what we see, I had to create the inside parts which goes in the main body, such as the chairs and the hand control, including also I designed the windows and the doors, but I didn't design the housing. It was designed by Chris. This is the hardest part that I created, the roof. It was hard because I had to use both the generative shape design and the part design. So what I did, I created a lot of points and joined them with lines, but in the end I actually realized that I could create the half of it and mirrored it, but before I didn't think about it, so I ended up finding the coordinates of each point at the end of the roof and then joined them. Then after joining them, I used part design to get the whole roof.
So this is the second tram body, and right away I'm sure you can see that it looks fairly similar to Marie's. However, the only part that was shared between the two of them was the actual walls of the tram itself, and I'll go into detail about that on the next slide. The second tram body was comprised of 113 total parts, with 30 of them being completely unique. One of the biggest challenges regarding the tram itself was that a lot of the support drawings lacked the necessary detail to get the angles for the sides right, including the roof and the floor itself, which you can't really see. And in order to overcome this, I really just had to kind of guess and check and make sure that everything lined up when it was going to be assembled. And I had to really hope that as long as my parts fit together, that the tram body itself would fit onto Marie's tram that she had made as well. Thankfully, everything did. In the end, there was a pretty fun mix of challenging, and there were also some slightly relaxing parts on this, like the windows, which some of them were just rectangles on rectangles. But the roof itself, I had the same challenge as Marie with GSD and making 15 different planes just to get all the support curves in the right spot. So this is the actual tram body itself, and while it's supposed to all be one big part according to the worksheets that we worked off of, I thought it was best to break it down into quite a few different parts because it just made sense to break it up where the angles changed. That way it wasn't a massive headache to create all at one go. And since all of the sides were effectively mirrored, it was a lot easier just to break it up and design it that way. I could have used the generative shape design for this if I was going to build it all as one big thing. However, that would have just been a massive headache, and I really wanted to avoid that.
So from the exploded view, you can see how all of the sub-assemblies interact with each other and connect together to form the full train. For the exploded view, all 357 parts were moved to show the relation for each individual sub-assembly and how they finish connecting to the final product of the train.
If you have any questions, you can direct them to our complaints department.
Thank you.